22. And we are on question 13. The given triangle ABC is right angled at B. Calculate the area of the triangle ABC. Area is a half base by height. Okay? And a half base by height is basically, this is the base. And this one here is the height. Now, the trick is, it doesn't matter what side you use as the base and what side you use as the height. You always get the same answer. So, an example would be, this is going to be a half, the base is 20 and the height is 15. So, half 20 times 15, anybody? 150 meters squared. Calculate BD, which is in blue. It's the same triangle. How do we know it's the same triangle? 20, 15 and 25. The area of this triangle is, anybody? 150. Let this be the height h, and this distance here is the base. So a half 25 multiplied by h must equal 150 meters squared. Half of 25 is 12.5. 12.5 h is 150. Divide 150 by 12.5, what do we get? I think it might be 12. Yeah. 12 meters. Who got that? Okay. Now,
sir, I thought you couldn't use 15 meters as the height.
It's not. I'm not using 50. Okay. So James, what it does is it depends on the way you rotate the. It depends on what way you rotate the triangle. So example, I'll give you an extra example just to hit the point home. Okay. I don't want that one. I want this one here. Okay. Here's a triangle. It's a 12, 13. Oh, sorry. I'll make that into a 5. Okay. This triangle here is a 5, 13, 12 triangle. Happy with that? Yeah. Area of the triangle is half the base by the perpendicular height. You happy with that? Then what we're going to get here is this. We're going to get a half 12 times 5, which is 30 meters squared. Okay. Now, what can happen next, James, is I get this triangle, and what I'm going to do is I'm going to rotate it around. So now that the 13 is technically the base. Do you understand? Now, 13 is the base, and what I need to do is find the height from here to here. So do you understand? This is now the height. Yeah. So once again, this height here, if I multiply a half 13 by the height, it's still the same triangle, which means it still should be the same answer. So I'm going to get 13h equals 13h equals 60. And what's 60 divided by 13? Anybody? 60 divided by 13? Now, we'd expect this number to be smaller than 5. Can anybody tell me why I'm expecting it to be smaller than 5? Because the side of 5 is obviously bigger, because that's the two sides added together, so basically it should be bigger. So what do we get for that?
4.6.
So the height would be 4.6. Yeah? Yes. Now, so that's the way it works. You can take any side you want as the base, provided you have it going up at 90 degrees. You need a line going up at 90 degrees, the full height of the triangle. Okay? Moving on. Number 14. A group of students wishes to calculate the height of the Millennium Spire in Dublin. The spire stands on a flat level ground. Maria, who is 1.72 meters tall, looks up at the top of the spire using a clinometer and records the angle of elevation of 60 degrees. Her feet are 70 meters away from the base of the spire, and ultimately measures the circumference of the space of the spire to be 7.07 meters. Oh, that is a hard question. Okay, here's what we're going to do. Here's the girl. This is Maria. Okay, Maria looks up to the very top. Now, the one thing you got to remember is Maria is looking to the center. See the way it's the center? Okay, I'm going to draw that all the way down. Now, what type of triangle do I have? Right angle triangle. Now, the distance of here to here is what, guys?
70.
Sorry, made a mistake there. Just give me 1 second. It's actually not that distance. It's actually the distance. I need to change colour here. It's actually the distance from her feet all the way over to the middle. Do you understand? That's 70, isn't it? Now, what type of shape is it on the bottom?
That's the base of the spire.
Oh yeah, so to here is 70. You're correct, Brian. So from Maria's feet to the base of the spire is 70 meters. Yeah? Happy with that? Now look what happens here, guys. The base of the sphere is what type of object? Oh, sorry, the base of the spire. What is it? It's a circle, isn't it? Yeah? And what we're going to do is we're going to figure out what is the radius of this circle. And how do you find out the radius of this circle? Anybody know? What does it tell us? Keywords. Circumference of the base is 7.07. What's the circumference formula? Anybody at all? 2 pi r. 2 pi r equals 7.07. R equals 7.07 divided by 2 pi. What is that in the calculator? .125. Now guys, that equals 1.125 meters. You got that? Now, what happens is, we now know that the full distance is what along the ground? Add them together, yeah? So the full distance to this central line is going to be 71.125. Now, the next thing I'd like to do, which is I want to explain what a clinometer actually is. I don't know if any of you remember it, okay? A clinometer is basically a protractor. It's a device that measures elevation. Now, in your leaving cert or junior cert, what you're going to be getting is a lot of this. Okay? You're going to turn it upside down, like so. Now, what happens is, there's a way hanged from the 90-degree mark. So do you understand what I mean by that? There's a line hanged here at 90 degrees. Right? It has a weight. And what this weight does is it makes sure it goes directly down every time. Right now, I'm looking directly across. Okay? So that means I have 0 degrees. Do you understand? Now, what happens is when I look upwards, and what's going to happen is I'm going to look upwards, and I'm going to look this far up. Okay? And that's where I'm looking up now. Now, do you know how I find out this angle here? Do you know how I find out? Sorry, I just adjusted there. Do you know how I find out this angle here? Can anybody tell me? How did you find it? What was I at before I moved it? Can anybody tell me? What did it read before I moved it? It read 90 degrees, didn't it? Yeah? And then I moved upwards, and now I'm stuck here. What does it read now? Can anybody see that number? 140. What's 90 from 140? It's a 50-degree angle. That's how it works. And remember, the closer you are to an object, the higher you have to look up at it. So if I did this one here, if I did this angle here, what do you think this one is? So this angle here would be from this one here to this one here. Anybody know? What does it say? About 165. So that's 165. What was my initial reading again? When it's hanging directly down? 90. 90 from 165? 75 degrees. Would you reckon that's close to 75 degrees? Quite a high angle, isn't it? Okay, so look, that's me explaining what a clinometer is. So anyways, this girl, she uses the clinometer, and what she gets is what angle to the top of the spire? What angle? Elevation of 60 degrees. Jack Doran, are we expecting the height of the spire from here to here? See the 2 black dots? Are we expecting this to be bigger than 71.125 or smaller than 71.125?
Bigger.
Why?
Because it's the angle bigger.
Exactly, the angle's bigger than 45, we're expecting this length to be bigger. Now, what function should I use? Sine, cos, or tan?
Tan.
Alright, good man, Brian. Tan 60 equals what? H over 71.125. Cross multiply. H equals 71.125 tan 60. What do we get? Anybody know? Huh? What you got, Brian? Sounds about right, doesn't it? 123.19 meters. Now guys, is that the height of the full sphere or the full spire? Why not? What have we not taken into account? So what do we have to do? Add on to 1.72, and what do we get? 124.91 to the nearest meter. 125 meters. Lads, sorry, that's the answer to part 2. The answer to part 1 is we use the circumference formula and find the radius of the bottom of the spire, don't we? Is that right, Alan? Okay. Alright guys. Moving on. Number 15. Mary is thinking of buying a new television. The television is advertised as having a 40-inch screen. This refers to the diagonal measurement of the screen. The aspect ratio of a television screen in the ratio of its width to its height for this television is aspect ratio of 16 is to 9. 16 units wide for every 9 units in height. So guys, what about this? Would this make sense? 16x and 9x. Do you know what I mean by that? It's not. It's basically for every 16 units this one gets 9. So if you put x equals 1, the lengths are 16 and 9. When x equals 2, it's 32 and 18. But you got to remember, their diagonal, it has to be how big? Their diagonal has to be 40 inches. So we have to figure out which diagonal works. Okay? So we'll figure that out in a second. So what we can do here is we can say that this is 9x and 16x. Next thing we're going to do is convert 40 inches into centimeters. How do we do that? Anybody? 40 multiplied by 2.54. So let's see what happens here. What do we get? 101.6. Okay, find the width and height of the screen in centimeters. Give your answer to nearest centimeters cubed. Okay, what do you think we can do here, guys? Anybody have any ideas? Pythagoras' theorem? Maybe? 101.6 squared equals 9x to be squared plus 16x to be squared. So let's figure this out. 101.6 squared. And we get 10,332.56. Now, what's 9 squared plus 16 squared? Forget about the x squared for the time being. $337. It's 337 x squared. Divide that by 337. 10322.56 divided by 337. And we get 30.63. 30.63 is equal to x squared. Now I'm going to square root it. Square root the answer. X equals 5.53. Now guys, what does that mean regards to height and length of the what does that mean in regards to length, or sorry, what does it mean about the height of the television? I need to multiply by 9. Okay, so 9 times this answer here to the nearest centimetre. It's going to be 50 centimetres high, correct? So that's 50 centimetres high, and then I've got to multiply it by 16 to find the width. There's our 5.53 there, multiply by 16, and our width is 88.55, which rounds up to 89. So it's 89 wide and 50 up. A different 40-inch television screen has an aspect ratio of 4:3. Which of the two TV screens has the greater area, and by how much? Okay, let's get the area of this one while we're waiting. What's the area of this one, guys? Anybody know? How do you get the area of this TV screen? 50 by 89, and what do we get? 4,450? Yeah? Centimetres squared. Now guys, the next TV, or the new TV, what does it mean about the new TV, guys? What do we know about the new TV? Can anybody tell me? Here's the new TV here. What do we know about this distance from here to here? 100 and? What does it say was? 101.6 centimetres, yeah? Or the 40 inches. This one here is going to be 3x. This one's going to be 4x. Once again, do Pythagoras' theorem. 101.6 centimetres. Sorry, 101.6 squared equals 3x squared plus 4x squared. That equals 25x squared. What was 101.6 squared again? A 10,322.56. Now, divide by 25 and square root it. Divide by 25, square root answer, and we get x equals 20.32. Now 20.32 is x. What does that mean about its width, guys? Its width is 3x, which is going to be, multiply it by 3, and we get 60.96. And then its length is 4x, which is going to be, divide that by 3, that's what it was, multiply by 4, and we get 81.28. Now guys, we now know that this here is going to be 60.96 multiplied by 81.28. We're going to multiply them by each other. And what happens when we multiply them by each other? We want to get the area. Length by width, remember? 4,955. Which one has the biggest area? Which one? Second one. By how much? .505 centimetres squared. Who got that out? Sorry, it's a tough question. Okay, 16. Find the values of A and B in the given diagram where the right angles are indicated. Okay guys, this triangle down the bottom, what type of triangle is it? What type of triangle? Can anybody tell me? What? Right angle. More specifically, what you know about the two lengths? Which makes it an isosceles triangle. If this is 90, this angle must equal this angle. So what does that mean the x values are? 45, because all three angles have to add up to 180, Robert Dahl. Okay, so 45 and 45. Now that we know what we're doing, okay, can we find out this length here? Let's call it x. How do you find out this length here? Anybody have any ideas? What could we do? Pythagoras' theorem. X squared equals 1 squared plus 1 squared, which gets us equals 2. X squared therefore equals plus or minus root 2 in third form, so I'll leave it as, sorry, not plus or minus root 2, just root 2, so just leave it as root 2. 1 by 4, 1 4 is correct, but it's not third. Okay, now that I've done that, what we need to do next is we need to draw the, hopefully it's still in red. Nope. Let's go again. Let's draw the yellow triangle. So we can see this triangle here, do you got it? This triangle here. Now, what we know about this triangle is this is A, this is B, this is 60 degrees, and what we know about the length x is it's root 2. Alright guys, so anybody have any ideas how to do this? Compared to the 60 degrees, what is the angle A? Compared to the 60 degrees, what is angle A? What's its label? Opposite, adjacent, or hypotenuse?
Opposite.
The angle A. Or sorry, length A. Hypotenuse. What is the number root 2? What's the root 2? Adjacent. And finally the B is? Opposite. Let's figure out how to get A. It's hypotenuse and adjacent. What function do we use? Huh? Cos 60. Cos 60 equals root 2 over A. Bring the A up and the cos 60 down. A equals root 2 over cos 60. What's root 2 over cos 60? I'm pretty sure it's 2 root 2. Anybody get it?
Yeah, 2 root 2.
Okay, it's 2 root 2. Just check it out just to be sure. 2 root 2. Perfect. A is 2 root 2. You have an option. You can now do Pythagoras' theorem because you have two lengths, or you could try something else. What function do you use if you want the opposite but you have the adjacent? O and A. Tan. Tan 60 equals, anybody? B over root 2. Root 2 tan 60 equals B. I think it's going to turn out to be tan root 6. What do we get? Root 6. B equals root 6. A is 2 root 2, B is root 6. And that's our answer. And that's that done. 20